Hello, my name is Joshua Hernandez. Thank you for joining me. This is exciting for me. I get to talk about something that I've never heard before. Lahars, I didn't know the term. When I started, I didn't want to do volcanoes or earthquakes because that was something that we learned about. I want to try to do something that was maybe interesting that I hadn't heard before, or something that, would be, I wanted to try to go out of the box. So today I'd like to talk about lahars, basically volcanic mud flows. If you are like me, you're asking yourself, what is a lahar? According to the Washington State DNR, we're looking at a mud flow. As we can see from the picture, this is Mount St. Helens. Eruption, approximately March of 82. And the heat from the molten rock has melted the snowfall, combining with the ash column has made this mud, this thick mud. Unfortunately, these thick mud can be very destructive and very damaging to the environment. According to earthhow.com, lahars, they need two things just to exist. We obviously have to have the way the debris travels, which is going to be the water. And then obviously the ash column is what's going to create the debris. And then you have your pyroclastic flow. And then this is important because there are two categories of lahars, primary and secondary. Primary can be during an eruption, as we've seen with Mount St. Helens before, where the heat causes the snow melt to pick up the debris. But then there's also times where inactive volcanoes can cause heavy rainfalls, can pick up with the volcanic debris, and also cause lahars whenever it's not active. So that's the secondary. That could be decades after the eruption. As you can see, according to USGS, more than 44,000 people between the 16th century and then 2010, that's pretty substantial, in my opinion. With that being said, this is one of the most deadly volcanic hazards. What are the most common types of lahars? Well, according to earthhow.com, as we've seen with Mount St. Helens, the hot molten rock, melts the snow caps. Now also, we talked about the rainfall. Colombia, Philippines, these type of areas can have seasons where they have a decent amount of rainfall. Well, this rainfall with the warmth from the volcanic molten rock and the debris from the post eruptions can cause these lahars whenever it's not active. And this can be very dangerous because they could possibly travel up to 65 kilometers an hour. That's very fast. And spread out to the base, hundreds of kilometers. This could be very scary for people that are living near volcanoes. And then this is an Indonesian word, Lahar, and it means mud flow at volcanoes in their language. I thought that was interesting. According to USGS, these lahars are occurring commonly at stratovolcanoes because they have the huge ash columns that are creating our material debris, extra material for the lahars to use, for the water to use to create that lahar. So it's kind of it's giving it the materials. This is very problematic. They can grow 10 times their size as they go down slope, wiping out anything. It's been said to appear as concrete that's being poured, as we've seen in construction sites. That's what they say they describe it as. It's rolling down the hill extremely fast. Imagine concrete coming down the hill extremely fast towards you. It can also be rainfall, snow melt, but also lake breakouts. So pyroclastic flow could act as a natural dam to block off a stream, river, body of water, and then that builds up and then diverts down the side of the volcano, picking up debris, causing that lahar as well. This picture is Bacolor in the Philippines, Mount Pinatubo. There was a devastating lahar. They were devastated by lahars many times from Pinatubo. Here we have a case study. There was many scientists that were trying to correlate the 1913 eruption of Volcán de Colima in Mexico, which was a Plinian eruption. And a Plinian eruption is basically a eruption with many blasts, boom, many events, huge ash columns that appear to that give that shape whenever you've seen a nuclear bomb go off. It gives that big huge plume. These give these big huge plumes, which is that debris that cause these lahars. And they also, the Plinian eruptions can collapse some of these pyroclastic tubes, and then that can hollow out to lead to more lahars, more destructive lahars. And basically they were trying to test, since 1913, the eruption, Plinian eruption, they had two mass casualty lahars that claimed mass casualties, approximately 600 people. And the first one was around 1916, 1916, and one of them was around 1950, and they claimed mass casualties. So some scientists took samples, the deposit of the Lahar, and they did stratigraphic analysis of the layers, and they did with the geological timing, and they basically looked at the texture and seen how the 1913 eruption made these ravines that would cause the lahars to be worse. And this is important because geologists are helping to mitigate the casualties, which is extremely important. As I said earlier, stratigraphy. This is important because this is one of the geologist tools that they've used before they had the carbon dating and then the radiometric isotope dating, one of the oldest forms. And this is how they assess these sites. and how long these layers have been there. This was a really bad eruption, extremely dangerous Lahar, November 13, 1895 in Tolima, Colombia. With the meltwater and the snow, there was a very large snowpack on top of on top of the volcano, and then with the seismic shaking, and then the eruption, it melted the ice, liquefying the volcanic deposits, and then it rushed down slope, increasing at a very fast rate, and it was catastrophic. It killed more than 23,000 people. This is very sad, and this was an article that was done by many scientists that talk about the impact, and they did an assessment basically of the deposits of this volcano, and they talked more on the volcano. I just wanted to mention a little bit about one of the most dangerous lahars. The risk of the hazard, as we've seen, environmental damage, economic, carries your house away, concrete river can bury your agriculture. Now, they can be cold or extremely hot. And then, according to the USGS, they can have different contents of the sediment. So they can be extremely dense with the material, or as like a milkshake, like a slushy, like very, like not as much material. So they can differ. The thickness, the density, of the lahars. What can we do to help out the situation when it comes to lahars? Well, as we mentioned earlier, since they can travel 100 kilometers, it's good to mitigate some of the loss of the damages. Well, how do they do that? Proper land use. Well, don't put houses and schools in the zone where it could be damaged. Make barriers. Engineer certain barriers that can sweep it away, divert the lahar a different way around living spaces. Systems to alert people as soon as they know that lahar is going to happen. And that's important because these other case studies that I've talked about, these help to mitigate some of these things by studying the different layers of the volcanic rock. And then most importantly, how to respond and how to recover from. This is a diagram of what we just talked about. Avoid putting the houses near there. Engineer some kind of basin to direct the lahar a different way. Warning signals, bells, anything that goes off, any type of warning so people can evacuate. And then obviously how to get people to the hospital quickly, how to lessen the number of casualties. There's our references. Thank you very much.